This is Kyle Kester. It's a video project for Physics 1 using dance and physics, or physics and dance. Every sport is reliant on basic tenets of physics, from NASCAR to water polo. Dance is a technical sport that requires the correct execution of moves backed by a knowledge of the physics behind the motions. These requisites allow a dancer to balance, spin, leap, and partner dance. The tenets of physics explored in this class that apply to dance include velocity, momentum, forces, vectors, angular velocity, angular momentum, and torque. Velocity is the speed and direction of the dancer's motion, and momentum is the dancer's mass multiplied by the dancer's velocity. A force is a push or pull given by a magnitude and a direction. A force applied to an object can change its velocity or momentum, provided that the forces upset the object's equilibrium. Equilibrium is attained when the net force is zero. Forces are added using vector addition, which sums the x, y, and z components of all the forces acting on a dancer. When a dancer is in equilibrium, the weight force downward through his or her center of gravity plus the normal force upward through his or her feet equal to zero. Collins, 2000, on a slanted surface, both friction and normal force oppose the weight force to yield a net force of zero. If a dancer begins to get off balance, the foot can be shifted back under the center of gravity, or a body part can be moved to realign the center of gravity over the foot. This keeps the net torque at zero. Angular velocity is defined as the speed at which an object spins combined with the direction of rotation about its axis. Angular momentum is rotational inertia, the equivalent of mass in the momentum equation, multiplied by the angular velocity. Torque is caused by force on the part of the object anywhere but the center of gravity. When a dancer's center of gravity is not over the dancer's contact with the ground, a torque is formed by the equal and opposite normal weight forces. Because these forces act away from the axis of rotation, the dancer tips over and loses balance. Friction applies a resistance, and therefore a torque, to a spinning dancer, which reduces the angular velocity and momentum. A spinning dancer can manipulate their rotational inertia because rotational inertia depends on both the shape of the dancer and their weight. By extending or retracting their limbs, they can change their rotational inertia. Harvey, 2014, due to the conservation of angular momentum and the relationship between rotational inertia, angular velocity, and angular momentum. Increasing the rotational inertia decreases the angular velocity. From Collins, 2000. Extending a leg or arm increases rotational inertia, which decreases the angular velocity of the dancer. This is how dancers modulate their turn speed without applying any torque. Jumping depends on the dancer's ability to create an upward force that exceeds their downward weight force. From Harvey, 2014. Their weight depends on their mass. As mass increases, so does weight. Momentum also depends on mass. Increasing mass makes it harder to start the dancer in motion, as well as stop the dancer from motion. From Fermilab, 2003, a more massive dancer will, therefore, have to exert a greater force to jump as high as a lighter dancer. In midair, the only force acting on the dancer is that caused by gravity. To jump in time with music, a dancer must understand the initial velocity, vertical velocity of a jump needed to execute the maneuver in a certain amount of time. For example, if a dancer wanted to jump so that their center of gravity increased 1 foot in height and spent 0.5 seconds in the air, he would have to leave the ground with an initial vertical velocity of 8 feet per second. Horizontal velocity has no effect on air time. It only determines the shape of the parabola that the dancer's center of gravity follows through the jump. Collins, 2000. In conclusion, many facets of physics are used in dance. As a dancer moves and balances, forces, velocities, rotation, and momentum are constantly changing. A solid knowledge of these subjects can help a dancer to elevate their dancing and better understand how to move to achieve their desired goal. Thank you very much.